and welcome everyone to this month's Connect with Remedy webinar. Before we get started, during the session you'll be able to ask any questions and answers to our panelists and interactively, and during the conclusion of the presentation, Rajeev will actually take live questions interactively to answer any specific questions you may have. This webinar will be recorded and will be posted within a week of today's live showing. And so without further ado, we'll go ahead and get started with Remedy 9, a holistic ITSM application performance troubleshooting look. Today we have Rajeev Patel, who is a lead product developer. Rajeev, I'll let you take it away.
Thank you, Gregory. Thank you, Ruth, and thank you, Steve, for making this happen. Good morning, good evening, good day, whatever the case may be. Welcome to today's Remedy webinar. As you can see on your screen, the topic is Remedy 9, Holistic ITSM Application Performance Troubleshooting. And the following slides, the slides that follow in this presentation will cover some part of the entire spectrum, as much as I could fit into basically an hour's worth of presentation, 45 minutes to an hour. There's a lot of information out there that can be collected and analyzed in order to look at a performance issue in your environment. And I'm hoping that today's information will go part of the way, if not all the way, in helping you troubleshoot issues that you might end up facing in your environment. So let's get started. So the agenda today, loosely on your screen, the problem definition, a brief overview of the architecture for Remedy, different kinds of logs that I've used over the years, Fiddler, client-side logging, mid-tier AR server and database logging, log analyzer, AR has a log analyzer tool, actually a couple of them, and then, making changes. And included in all of these, some of these will be case studies that I've, from customers, real customers, that have benefited from, performance troubleshooting over the years, either, through me or through others in the performance team. So the first and the most important thing is to create a problem statement. Usually, a database administrator, or in the case of Remedy, an AR administrator, will get frantic messages or calls, sometimes not frantic, from users who are the ultimate consumers of the application that something is awry, something is amiss. It could be the overview console is taking time to load, or an incident save is taking time, or the login is taking an inordinately long time. And so the first thing to do is to define the problem. What is that use case? What is actually happening? What is that user doing? Is it the loading of the overview console? Is it, are they processing jobs in RE or normalization? Are they creating tickets or, incident change, problem management, whatever the case may be? Was it that the throughput was much higher before and it's fallen because something has happened, some change has happened, something has occurred, a fix in the system, something. Or it could be that instead of your throughput, it could be the response time. Maybe a ticket is now taking 15 seconds to save. And then obviously something has changed, and what has changed, it might become a little clearer, and maybe it might ring a bell in the collective heads if you make a list of things that have changed. For example, was a Remedy hotfix or a patch applied? Was an operating system patch, a database patch? Was it a database level upgrade? Maybe a new index was created that you weren't aware of by the DBA or someone in the team. It always helps to ask the question, what happened between last Friday when performance was fine and today, Tuesday, when performance seems to have degraded for all, if not all of the users. So that always is the first step, and that's what I usually end up doing when I'm dealing with customers, either in person, wherever they are, or in WebExes and phone calls. So a brief overview of the Remedy architecture. We have the client. The client could be a laptop, a desktop running a browser. And the browsers that we've encountered over the years that Remedy supports are IE, Chrome, and Firefox. You have your mid-tier and your web services, and you have your AR system server, 8x, 9.0, and 9.1. And then your databases, basically, SQL Server and Oracle. And, these are different versions, and I believe, we support versions, of SQL Server that are higher than 2014. Oracle 10G, 11G, and 12C. Some changes in 12C that have adversely sometimes affected customer performance, and we may or we may not get to that in the slides, but we can do that during the Q&A at the end. So the client usually, when I'm dealing with customer problems, the first thing that I usually look at is the browser. Is the browser supported by Remedy? Is it a version that's recommended by Remedy? There have been, in years past, I'm talking about 7, 8, 9 years ago, I was dealing with a bunch of customers whose company, the customer's company, it was mandated that IE would be the browser that people had to use. And, I'm trying to remember, in those days, they were running IE6, IE7, and IE6 was much slower compared to slightly higher versions of IE, like 7 or 8 or 9. And so the first recommendation that we made to those customers was to upgrade from 6 to a higher version. So, it's always good to run a recommended version, BMC recommended version of the browser, not just the browser itself, but the version of the browser. I use Fiddler, Cap, and Fiddler on and off for tracking problems from, from the client side, because Fiddler basically records traffic between the client and the mid-tier. And then I also have clients generate AR client-side logs, and we'll get to some more details about these different options. So again, as I said, BMC recommended version of the browser. In your environment, it might be prudent to check the performance of IE, Chrome, and Firefox for different use cases. And you might find that if you're allowed to use any of these browsers, you might find one browser might be, a better option than the other two, or even, for certain use cases, you might end up using certain browsers. I would recommend turning off any unnecessary plugins. We end up installing plugins. Either they come with your image when your laptop or desktop was configured, or you end up adding them as time goes by. You might want to turn off those unnecessary plugins. And one of the things I've noticed over the years, it's much less so now because people are getting more and more aware of this, is to not clear the local cache, the cache on your laptop or your server upon exit from the browser, because what that means is the next time when you log in, images that need to be downloaded just once, unless they've changed, like, files that need to be downloaded just once, like images, etc., have to be downloaded again the next time you log in, and that initial login could be really slow. Fiddler, Cap, and Fiddler. You can use Fiddler to basically, define a baseline, and you can use it subsequently to measure deltas from baseline. If there, if suddenly a performance issue shows up, you could right off the bat, maybe once you've defined what that, or assessed, or gone to the user and found out, determined what that performance issue is, one of the things you could have that user do, or you could do it for the user, or you could do it on your own laptop, desktop, is to have a Fiddler capture, and then, especially if it's a user complaining about it, have the user do a Fiddler 2 capture, so that we can, take a look at a baseline if you have a baseline defined from before, and narrow or zero in on where the issue seems to lie. And Fiddler, Cap, and Fiddler do not require server access to install or to be run. Fiddler Cap is a lightweight version of Fiddler. I like to think of it as a wrapper around Fiddler. It generates archive files, and the extension is .saz. And you can open these in Fiddler too. And it basically lets you insert comments and actually take screenshots while you're performing the use case and capturing the traffic. And Fiddler 2 itself is a free HTTP debugging software, and it captures HTTP and HTTPS traffic, and you can save that traffic into an archive file and open it up later and do your analysis. And both of these are installed on the client machine, the user's laptop or desktop, as the case may be. AR client-side logs are basically it's a log of client calls made to the mid-tier, and there are a bunch of options when you configure this logging on the client side. There are a few options that basically you can select, and one of the one I really rely a lot on is the web timing, because it gives us timings, the time spent in each of these tiers, the client, the mid-tier, and the AR server, and then we can use those calls and the time spent to basically correlate these calls with your AR API SQL logging, filter API SQL logging on the AR server, so that you can have an end-to-end picture of what happened. If you find time was spent in the mid-tier and you've turned on your mid-tier logging, you can get an idea of what was happening in the mid-tier. Or if you find from the client-side log the time was spent on the AR server, you can look at the API call that happened approximately at the same time as your client recording of the time. Go to the AR log and look up what API was running at that time and what SQL statements were being issued, or what that API was doing. So a brief overview on how to use Fiddler Cap. You basically want to install and launch Fiddler Cap. Make sure you select the decrypt HTTPS traffic checkbox. Otherwise, since traffic is encrypted mostly, you might not get the actual back channel calls and stuff. And then click on the Start Capture. Basically, when you're performing a use case, let's say a user is having slow response times when he or she saves a ticket. So what I would end up doing is I would have that user get to the point, have the user launch Fiddler Cap and start capturing traffic, and just before he or she presses the save button, I would have them click on that little blue flag that you see on your screen, the annotate button, and I would have them put in a relevant comment. For example, it could be about to press save on incident ticket, for this incident ticket. And then once the save is done, and let's say it's taking 15 seconds, and that's the problem the user is now experiencing. Once the save is completed, the user would press that blue button again and put in a comment again that says save complete. What this does is it helps you in the Fiddler file, archive file that you will open up later to analyze. You will see comments in there, marked and highlighted, which would say about to save the ticket, and then after the calls are done, save completed, so that you know that for that particular button press, the lines in between those two comment markers are the ones that corresponded to the save action. It's a really powerful tool, really wonderful tool. This is what a sample Fiddler archive file looks like when you open it up in Fiddler 2, and we'll get to a little more detail. I'm sorry. So basically, what it shows you the call number on the extreme left, the result that basically came back, the protocol that was used, the host that you were running in your browser, and the URL that was basically sent from your client, the request that was sent from the client. So let's take a look at a sample Fiddler 2 analysis of a capture. And on your screen, this was from a real customer case some years ago. And basically, I was tasked with doing a Fiddler capture and finding out what was going on when these use cases were taking time. And in this case, you were logging into the mid-tier, selecting the service request coordinator console, entering the name Susan, clicking on the search button, and basically selecting a request, clicking on the details. And once the details screen showed up, looking at that screen, getting information, and then clicking on the log out button. And so basically, when you launch Fiddler Cap, it opens up a browser window because it has, so to speak, its hooks into that browser window, and that is where you would end up performing your use case in that browser window. So typing in your URL, going there, logging in, and all that stuff, and going through this use case. So basically, this is what that screen capture looked like. The first line in yellow on your screen, the fourth column, is it the fourth or the fifth column? The fifth column has a comment that says login. The second yellow line says, SRM, Service Request Coordinator Console, so that's what I clicked on that link. And the third yellow line is basically where I searched for the name Susan. And I realized, the calls that I was interested in looking at in more detail were the calls between the second and the third yellow lines. And those are how many? About 17 calls. And I highlighted those calls, and the right window, I clicked on the statistics tab, and that tab basically showed me that, I had 17 requests, the number of bytes that were sent, the bytes received, and the time it took for all those 17 calls to finish. And, let me see if the next screen, if I remember right, has some details. Yes, it does. It has details over here. So basically, as I said, the first, second yellow comment line was Service Request Coordinator Console and a search for Susan. Basically, there were 17 calls, and in these 17 calls, there were a bunch of back channel calls, and line numbers, I think, if I look correctly, line numbers 24 to 35. So basically, the last lines you see in the lines that are highlighted in blue, those were the calls that were back channel calls made, from the mid-tier to the air server. And so if we look at the next screen, the statistics for all of these 17 calls, it showed that this particular set of calls, 17 of them took 1.045 seconds. And as you can see, as I was saying, telling you before in a couple of slides before, it gives you a lot of information. Basically, the number of calls you've selected, the number of bytes that were sent, bytes received, and the request time that, the starting time of the request, the response completed at, and your sequence clock time, which is 1.045 seconds. One of the other tabs next to the statistics tab is something called timeline, and it shows you how these calls progressed, basically. And the next slide will show the timeline panel in much more detail. And as you can see, for that particular set of calls, the 17 calls that took 1.045 seconds, you can see that there was basically between call number 4, which is the udd.js call, and call number 5, or the license release servlet, which is call number 5, and then call number 6 started after call number 5, obviously. There was time spent between calls 4 and call 6, and this particular time spent was about 0.3 seconds. So the timeline tab gives us a much clearer picture of how the calls progressed and where there was a bit of time spent. It could be in one place, could be in more than one place. And so it helps us zero in on what might be a target area to focus on, and maybe get developers involved or whoever it is that needs that knows more about these calls, and see if we can make some headway in helping the customer solve this performance problem. So here is a real case study that I took. I helped debug at a customer site in Europe some years ago. It was noticed that a new search from the incident management console took more than 8 seconds. As you can see, it took 8.5 seconds. So I had the user perform a Fiddler cap capture, insert comments. And as you can see, there are 6 calls highlighted in the left pane in blue. And the statistics tab on the right showed that those 6 calls took a total of 8.5 seconds. So then I decided, I took all this information and zeroed in on those 6 calls. The summary was that there were 4 back channel calls among those 6 calls. And there were two of those back channel calls were GET calls, and the first one was both of these were JavaScript calls. Basically, the first one was a C59991 EC.js. The second was a UDT.js. As you can see from the screen, the first one took just under 3 seconds, 2.9, and the second one took 5.2 seconds. And if you look at the first number in red on top, out of 8.56 seconds, you're looking at almost 8.2 seconds of those 8.56 were spent on these two JavaScript calls. So the first call, JavaScript call, is basically because the back channel call before it was a get HTML script for view field call, and these two calls would be made if the current cached content has expired or the user has deleted their temp internet files. The second call, the one that took 60% of the time, was a udd.js call. Now, this particular JavaScript is basically rebuilt every time or built every time a user opens a new form. And it basically is based on information the mid-tier server has to query the AR server that each time this file is requested. One of those, one of the information pieces of information that comes back is a user saved searches. So in the case of this particular user or this set of users, this particular client has increased their saved searches to a really large number. The mid-tier has a configurable limit for saved searches, and there is a default value. Users who are having issues with this particular new search button action use case had created a lot of saved searches. They were performing searches all the time, and they were saving these searches. So what had happened is there were some users who had 900 or more saved searches. So the first thing we just had the users do was to not clear their cache. So we asked them to not clear the cache. That would minimize the time taken for the JavaScript, the first JavaScript, the EC JavaScript file. And basically the default of 90 on the mid-tier is through a parameter called AR system searches max allowed. Some of these users had 900 plus saved searches, and so basically what we wound up doing was in the database, the AR system administrator cleaned up these searches for those users, and once that was done, these new form search, the new search form opened up much faster, and we had a whole bunch of satisfied users, once that was done. Now on to the AR client side log. Basically, under the logging tab, when you open up your user preferences, you will see the logging tab. You click on that, and it opens up, where you can the screen where you can configure logging. And these are the ones that I end up selecting: active links, web timings, as I was mentioning before, and even on the server, API filter and database calls. And so we'll get into a little more detail in a few slides. On the mid-tier, basically, the performance box is the one I select or have the mid-tier. I'm basically an AR and database person, but so whenever there's a mid-tier issue, I do have some knowledge of the mid-tier, but I usually have them turn on logging, performance logging, and then get the mid-tier experts involved if I'm not able to solve that issue right off the bat with my rudimentary knowledge of the mid-tier. So getting on to the AR API SQL filter logging. So we're moving on to the third tier, so to speak. The first being the client, browser, Fiddler. Second one was the mid-tier, and the third one is your AR server. Usually, unless we think we're having issues with threads, AR server fast list, and other threads, we end up having customers turn on API SQL and filter logging, and recommend that they write all to the same file. It's not mandatory, but we would like the three to be written to the same file, so that we don't have to go through an extra step of combining 3 different files into one log file for the AR log analyzer to generate the output. And then there's something called the AR exception log that could be configured, and it's under your system general server information, server statistics tab, where there's something called enable exception logging. And the minimum elapsed time here is 5,000 milliseconds, which is 5 seconds. And this is obviously, you can change this if you feel, and this will basically log calls that are, the same or higher than this time that you've configured. As I said, the default is 5 seconds. If you feel, you can change it to a second, you can change it to 2 seconds, depending on, what your threshold is. But this, it's a really powerful tool to basically give you an idea of API and SQL calls that are taking longer than the time you've configured over here. Let's do a case study on AR client side and AR logs. Basically, this particular client, most of the use cases of this client side, it was a very large, at the customer side, it was a very large customer. If I remember correctly, they had in excess of 25,000 or 30,000, 27,000 support groups and about 5,000 companies. The response times were acceptable, but anything over 2 seconds, users were likely to say, that's not acceptable. And so the customer and BMC decided to look at these slower use cases. And one of the biggest pain points, again, remember the word pain is subjective here, as it is in real life for every human being. Opening the chain console was perceived to be slow. So I had the user perform, generate client-side logs in addition to AR server API filter and SQL logs. And the AR server that was being used, this exercise was, this use case was about 2 years ago, I'd say. So right now, I think even in the current binary, we're still shipping this so-called instrumented binary. So if you ever look at an AR server log file, you'll notice that you have these additional these additional messages that talk about that give you information like generating prepared statement or binding two parameters to prepared statement. And so the client side log has basically these calls: HTTP, MTT, and CLAT. HTTP call logs the time of request or response between the client, in this case the browser obviously, and the mid-tier. The MTT logs the time spent in the mid-tier, so received or sent back by the mid-tier, and the CLAT is the time spent between the mid-tier and the AR server. So it logs the time when the AR server received the call, from the mid-tier, and the time it sent it back to the mid-tier. So this was for a user AD something, and this was the client-side logs file. So when you turn on your client-side logging, and some of you might have done this already because you've done that on your own, or BMC support has asked you to do that. If you realize this, if you've seen this, it opens up a little window with lines that just scroll by at breakneck speed. And when you're done with your use case, you can basically save the output of that window to a file, and that becomes your client-side log file. And it has entries like the entries you see on the screen. As I was saying, you have HTTP, MTT, and CLAT calls in this case. So you just like the syntax for an AR API SQL filter log file, you have a plus and a minus. The plus being the start of the call, and the minus being the end of that particular call. So in this case, you have a plus HTTP call right on top, then you followed by a plus mid-tier, and then a plus API, minus mid-tier, and minus HTTP. So right away, when you look at the screen, you can tell that the HTTP call started at 58.11 seconds after 851 and ended at 59.39 seconds after 851. So doing the math, you can see it took about 1.28 seconds. And so let's see if the next slide gives us a little more detail. Well, let's go back to the previous slide. So if you look at this, if you look at the time spent, you can tell that the mid-tier received the call from the browser 0.017 seconds later, and the AR server is the one that, if you look at the call, the CLAT call, the plus API, minus API, you can see that the AR server is the one that spent pretty much all the time, almost 1.26, my math is telling me 1.264 seconds of the total time of 1.28 seconds was spent in the AR server. So right away, right off the bat, we know that we need to focus on the AR server because that's where 98% or 97% of the time was being spent. And since we had the user generate AR server, we had them turn on AR API SQL logging, we narrowed it down to this GLEWF call. As you can see, it started at 58.137 and it ended at 59.388. And the summary of this was that the whole call took 1.25 seconds, where 0.069 seconds was spent between the begin transaction and the SQL statement start. The SQL itself took 1.18 seconds to run. So basically, in this case, a little bit of time, just under 0.07 seconds, was spent generating a prepared statement which had 308 bind variables, out of which 288 were for row-level security check. And as I mentioned, this particular customer had in their database, they had 27,000 odd support groups and about 5,000 companies. And some of these users were users who had access to multiple companies and support groups spanning multiple companies. So in their case, their SQL statements were huge, and 288 checks were being performed at to see if a row was had the permission to be viewed by this particular user. And again, the SQL took 1.18 seconds to run. So therein we lay an opportunity to look in the database and see if there was room to improve the SQL in terms of maybe creating an index, having the database pick up an execution plan through other means, and so on and so forth. So basically, in conclusion, for that particular use case, given the fact that this company had so many support groups and customer companies, one of the things we recommended to the company was to implement something called hierarchical groups, so that you had a much smaller SQL statement, you had much fewer, far fewer conditions for row-level security, and so they did implement it. Their performance has improved, and basically, hierarchical groups is a way to go. In case I'm not saying it's something easy to implement; it takes time, but it's definitely a way to go if you have a lot of support groups. I've realized over the years that a SQL statement where a user has 20, 30, 40, 50 or more like conditions where permissions are being checked, those SQL statements do tend to take a bit of time to run, whether it's Oracle or SQL Server. So now getting on to the final tier, the AR Server database. As I said, the two biggest databases that we have in our customer world are SQL Server and Oracle, and each of these have their own set of tools that can be used to diagnose performance problems. SQL Server has the SQL Management Studio. If we have a SQL statement that we feel is problematic, we can take we can run that SQL statement in SQL Management Studio and get its execution plan. We can try and tune the SQL by creating indexes, etc., and see if we can get better execution plans. In the database itself, we have other options like SQL Profiler, the SQL Tuning Advisor. There are a couple of knobs we can tweak. Something called max stop, which is the maximum degree of parallelism. The default value is 0, and the cost threshold, and I'll get to this a little more in more detail. Something called the plan guide. Similarly, in Oracle, we have SQL Developer Studio, which is comparable to the SQL Management Studio in SQL Server. We have utilities like explain plan, auto trace, and a very, very, very comprehensive report called SQL T, So if you have a particular SQL statement that you know is running poorly, and you have the SQL ID, and the SQL ID is how a SQL statement is uniquely identified in an Oracle database, you can run a SQL report, and it gives you unimaginably detailed information about not just the SQL statement itself, but the objects, the tables, the views, whatever the case may be, for that particular SQL statement. You have, your AWR reports, and that an AWR report is run using a SQL called AWR RPT, which is an Oracle Home RDBMS admin, and you have something called ASH and ADDM reports. We get to a little more detail about these different options. Some of them, not all of them. In SQL Server, you have something called MaxStop, which is something that's a wonderful tool I've realized over the years to have SQL statements run in parallel. The default is 0, which means SQL Server will use all processors available on that database machine to run a query in parallel. Of course, you can change this value at the database level, and if you set it to 1, it means you're having SQL Server use only one CPU, and then any other value, basically besides 0 and 1, specifies the number of parallel threads SQL Server will use to run that SQL query in parallel. And you can configure that as you can see on the screen under Advanced for server properties for your server, that is your Remedy server, the database, and it's called max degree of parallelism. And there is another parameter called the cost threshold for parallelism, which basically works in conjunction with your max degree of parallelism. Again, this is something that you can configure in the same property screen as the max degree of parallelism. In this case, the default is 5. So what that means is every SQL that runs, whether it's running in SQL Server or it's running in Oracle, has something called cost that is associated with that SQL, and the cost is nothing but the database's estimation of what it would cost to run that particular SQL and return the rows or perform the actions that particular SQL is demanding of the database. So when you have a default value of 5 for the cost threshold of parallelism, and let's say your max degree of parallelism is set to the default or 0, which means that it would use all CPUs if when it's run. It will run in parallel and use all the CPUs only if its cost is 5 or higher, right? So if, for example, that query has a cost of 1, it won't run in parallel. So here is a powerful tool to use to make sure that not every single query that runs in your database is running in parallel. There are only selected queries, and obviously the word selected is a result of hopefully knowing your workload as an AR system administrator and as a DBA helping the AR system administrator keep the system humming along. It comes from knowing your workload. So, and obviously profiling, so to speak, the workload in the database in terms of SQL statements, how they're running, the high load SQL statements that are taking a lot of I/O, or taking a lot of time on the CPU, and profiling those SQL statements in terms of cost. So you would tweak these two values, the max stop and cost threshold for parallelism, and come up with a value for both of those that basically keeps your system running smoothly, and queries that would basically not have benefited from parallelism are now benefiting because you've adjusted the cost threshold judiciously. And again, this requires that you keep tabs on your system every so often. Every so often could be every few days, every week, every few weeks, every month, especially if you're rolling in new ITSM applications. You have change, but now all of a sudden 2 weeks from now you've introduced change. you've got more SQL statements running in the database, and suddenly things aren't working as they used to, and now you have to go back in and look and say, okay, I've introduced change. There's a problem. Going back to that first slide we had, problem statement, something new has happened. Yes, change has been introduced. Now you reprofile, so to speak, your database and adjust these parameters if needed. Just a simple example of how to look at a query in your SQL Management Studio. Remember, all of these are just first steps, rudimentary steps. I'm not about to delve into how to go about tuning, because at the end of the day, BMC is not a database company. BMC is an application provider. A lot of these activities should be performed at the customer site by the customer's DBA, and they should be done on a regular basis. And so the reason I've got these slides in here is because I'm aiming for AR system administrators. Knowledge is ultimately power. So if you actually have some knowledge about SQL statements, even if it's rudimentary, you can actually go through this exercise on your own, assuming you have the access to do so, permissions to do so. And please go back to the DBA and say, look, hey, look, I get the feeling that the SQL statement isn't running well. It looks like maybe we can do something with the cost, or we can do something with an index on this particular table, or these set of tables. And maybe the DBA can then go in and take a look, more detailed dive into the SQL and come back and say, sure, let's do that. And then you can create the index and hopefully get better performance. So this is basically something that you might benefit by, instead of going to the DBA and saying, hey, the system isn't running well, can you help? And the DBA might be extremely busy, or whatever the case may be, and they might not jump to it right away. So, if you can identify the SQL statement that's running poorly, you have knowledge. You can go back to the DBA with more information, armed with more information. So in this case, when you hover your cursor on that topmost left operator, which in this case is a select, it opens up a little window that gives you some information, and the key piece of information there is something called the estimated subtree cost. In this case, that subtree cost is 2.04. And to the right of that top leftmost operator are the other operations that happened when the SQL was run in order to satisfy that SQL and bring back the rows, the user. And each of those operations has an associated cost, and that cost is shown right below that operation, the little graphic, the GUI for that operation. And it might be a nested loop, or it might be a sort or a filter, or whatever the case may be. And all of those costs add up to that total cost you see in that yellow box. In this case, it's 2.04. For each of those sub-operations, you can do the same thing. You can hover your cursor on that little operation, and it shows you the cost for that particular operation. In this case, somewhere in the middle of that yellow is basically something called the estimated subtree cost. In this case, it's 1.94. I know this because I'm able to read this, and I'm the one who generated the slide. I memorized that, but I'm so sorry the graphic isn't that clear. But the value is 1.94. So we know that out of 2.04, this particular operation took 1.94, contributed a cost of 1.94. So we know that this is where we need to focus, right? And other pieces of information are in that little yellow graphic. One of the most important ones is the one on the bottom, the object that was used to perform that operation. In this case, it happens to be a primary key on that table, T1382, and as we know, the primary key on most tables in Remedy is the column C1, and basically the seek predicates were for that particular operation, C1 equal to something. And so right away, as an AR system administrator or even a DBA, you know that this is the operation you want to zero in and focus on. So basically, a recap of SQL Server, use your SQL Management Studio to obtain an execution plan for your SQL and find the operation or operations with the highest cost or costs. And quite often that when you actually run that SQL statement, you might have a recommendation come back from the SQL tuning advisor. More often than not, it's an index, and basically that index, the recommendation will come with the column or columns to index and the percentage improvement that you're likely to get as a result of creating that index. And 2 weeks ago, I was involved with a customer where we were looking at a particular SQL, and the SQL tuning advisor came back with the recommendation for an index where the percentage improvement, if I remember correctly, was 95.8%. That particular use case was taking, that particular SQL was taking anything between 40 and 50 seconds to run, if I remember right. And we created that index, and the time dropped to 1 second. And right there, we had a happy customer. That escalation case was closed. And it's, well, I don't want to say it's rare, but usually the tuning advisor comes back with a percentage improvement that could be anything like 5%, 20%, 40%. That was one of those rare cases where I saw something like a 96% improvement in the SQL itself. And this is something that I would recommend, DBAs and AR system administrators do on an ongoing basis. Run your SQL profiler in the SQL Server database, have the DBA generate the top SQL statements either in terms of time spent on the CPU or physical reads or logical reads, whatever the case may be, elapsed time, and take a look at these SQL statements. Run them in your SQL Management Studio and see if it comes back with some kind of a recommendation, and go back and see if that index really helps. Experiment, as I said, with the max stop value, and you can actually run a SQL statement you've identified as being a slow SQL by putting this little syntax at the end of that SQL statement. So let's say you grab that SQL from your AR log file. We have this SQL with your literal values. You put this option and then in parentheses max stop and the value or n, which could be 4 or 5 or whatever the case may be, and run it and see if running it with or without parallelism has an impact. So then you can actually assess whether parallelism will benefit your SQL or the database as a whole. And if all of that fails, there's something called SQL Plan Guide. If you manage to get a SQL execution plan from a different environment, not your production, maybe your test or your development environment, that seems to be a better execution plan because it runs faster over there, as SQL does. You could take that execution plan and have the SQL in production use that particular execution plan by having or using a Microsoft SQL feature called SQL Plan Guide. But I don't want to get into that right now. I usually recommend if your DBA can do that, that's great. If they have never done that, maybe they can read up or get Microsoft support involved. And I've had customers use plan guides, and the only caveat is that if you have a plan guide in place, you need to keep monitoring your database and make sure SQL statements that are using the plan guide suddenly haven't changed because something has changed in your environment. They're no longer using that plan guide, and now your performance has gone to hell in a handbasket, so to speak. So again, you have something in place in the database that isn't out of vanilla remedy. You need to keep monitoring it and make sure that they're being used, those features. Going to Oracle, similarly in Oracle, you have something called Explain Plan that can give you an estimated execution plan. Usually these estimated execution plans are quite good in terms of how accurate they are when that SQL actually runs in the database. It's very rare that I found plans to be different. So an Explain Plan is a great estimation of what the actual plan might end up being when that SQL runs. You have something similar in SQL Management Studio also, an estimated execution plan and the actual execution plan. And you can actually create something called the plan table, which is where Oracle stores the operations that are performed for that particular SQL execution. and you can explain that SQL using the syntax, and you can view the execution plan using this particular SQL statement. I don't want to go into detail in this particular graphic or the slide you see on your screen, but basically what this is a simple way to a way to read this particular explain plan output. You can go and read up online about explain plans and how to read them. Basically what's happening here is it's selecting, the select statement is selecting from two tables basically, employees and locations. And the employees table obviously has all the employees in the company, and loosely speaking, there is an employee and there's a manager, an employee's manager. So there's some kind of a flag, that basically stores whether it's an employee or a manager. And then each of those employees, whether it's an employee or a manager, has his or her location from a table called locations table. And so what's happening over here is, you have a SQL statement where the first condition in the predicate, the where clause is employee e.last name. So we know that in this case, we're looking for an employee whose last name, for example, is Smith. And what we're doing is we access using the employee's last name, and then we basically go to the table. And as you can see in the select statement, the first column that's being selected is e.first name. And so since we only have a value for the last name in the where clause, we need to go to the table and get that particular employee's first name. So we have to access the table, get the row, and get the first name. And so once you have the first name and that row you have the row, you also have what is known as the employee ID for that employee. So you now take that employee ID and you go and scan the table again and get the manager ID and so on and so forth. So what's happening is that's how you read the execution plan. Loosely speaking, well, to make it short, in an explain plan in Oracle, the most highly indented operation is performed first, and if there are operations that are equally indented, it goes from top to bottom. So if you look at the screen, on the bottom left, you have in parentheses operation, the second one in green, which is number 1 on the right. Since the most indented ones are operations 1 and 3, and since they're equally indented and it's top to bottom, number 1 gets executed first. And because 1 is executed first, it has to access the table to get the first name of the employee. So then the one above it, which is the table access, number 2 is executed second. And then the third one is the index, unique key in step 3, and so on and so forth. So that's how you read an execution plan and get an idea of what is going on for that particular SQL. And if you find that, oh, this particular operation shouldn't have used this particular index, or it's doing a full table scan, how can I improve this execution? That's the start of your tuning process using something called the explain plan. Now going on to reporting tools. These reporting tools are basically database-wide reporting tools. So these give you a snapshot of what is going on in your database when that snapshot was taken. In pre-ADI days, you had something called util bstat, estat, and I remember running these because I've been working with the Oracle database software since 1989, and I worked for Oracle in the database performance group between 96 and 2005. So I've seen all of these come and go. Util estat, bstat, estat was something in pre-8i. Something called StatsPack came in 8i, extended StatsPack in 9i. 10G had AWR, and 11G and now 12C has something called AWR extended. This is how you take a snapshot. So if you're an AR system administrator, it's highly likely that the only access you have to your database is through a user, your AR admin user, and so you won't be able to do this, but you'd have to either get permissions from your DBA to perform these actions, or you might want to have your DBA create these snapshots, right? These are ad hoc snapshots because Oracle, every hour, on the hour, takes a snapshot. Okay, so you basically if you look in your database, you can configure how long your snapshots are kept for. I think if I remember right, the default is 7 days. I can't remember now. But you can change that default to 14 days or 21 days, whatever the case may be. So you can have snapshots going back 7 days, and since it's a snapshot every hour on the hour by default, you're looking at 188 snapshots, right? 168 snapshots by default. But if you want to take a non-standard snapshot, so let's say you know that your users are experiencing a performance problem, and it's 9:27 in the morning on a Thursday, you can talk to your DBA, or you can do this yourself if you have the permission. Take a snapshot, wait for 10 minutes, maybe 15 minutes, and take a snapshot again. So you start at 9:27, you finish at 9:42, and then generate the report, AWR report, and hopefully that will give you an indication of what's going on in your database and where a potential performance issue is occurring. An AWR report, I mean, I have an entire presentation that I've done internally for people in BMC that goes into 70, 80 slides, detailed AWR report analysis, but it's too much for this particular webinar. But basically a summary of what an AWR report has. Right on top, you have aggregate summaries, a summary of the report. You have cache sizes. The biggest, most important caches are your shared pool, which is where your SQL statements are processed, where they live, and your buffer cache, which is where your table and index data are stored. So when you see buffer cache, think of data buffer. When you see shared pool, think of SQL cache. Your instance efficiency percentages. So the two important ones are your buffer and your buffer hit ratio and your library cache, basically. You have shared pool statistics, which is where, again, as I said, your SQL is being processed. Your top 5 wait events, and these wait events are basically things that you don't want to have happen in your database. If your SQL statement, the process is waiting for something to occur, that's a no-no. You want to try and minimize your waits or eliminate them. So this is an important area. And you have a SQL section which tells you the top, whatever SQL, and again, that's configurable, the top SQL sorted in descending order by elapsed time or buffer gets or physical reads. In this case, buffer gets is nothing but memory buffers, so logical gets. You have an advisory section for the buffer cache, again, data buffer cache, shared pool, which is a SQL. And then you have a section at the end where your Oracle configuration parameters with non-default values are highlighted. Obviously, since if you're running 9i, BMC recommends that your cursor sharing be set to exact. And since exact is the default value for Oracle, it won't show up usually. That's an example. I'm going to take a simple case study done many years ago for a real customer. This is what a SQL section looks like. It obviously has more SQL statements. I've just taken 2 of them here. And as you can see, it shows you in the first column, and this is an older report. Newer reports have far more information. This is from, I suspect this is from 9i, from some years ago. You can see that the first SQL statement had 589,000 physical reads. It ran 8 times. And obviously, 589 divided by 8 gave you how many reads it did per execution. And what's important here is those 2 columns, the CPU time and the elapsed time. The CPU time in this case was 51 seconds, and that's the total CPU time for those 8 executions, so it spent about 6.5 seconds was on the CPU. But the elapsed time was 5,776 seconds. If you divide that by 8, you get the time it spent pretty much on each execution. And for the second SQL statement, it only ran twice, but it took 6,000 seconds each time it ran. And only 15 seconds of those 6,000 seconds were spent on the CPU. So that's telling you that these SQL statements were doing a tremendous amount of I/O. They were spending a lot of time doing I/O, mostly. And so potential area for tuning. And as you can see, an AWR report, well, this is more important for people within BMC and stuff. But if you look at the SQL module there, it's showing you it's arserver.exe. So you know right off the bat, well, you obviously, as an AR system administrator, you know your system, so you know what version of Remedy you're running. When I get a report from a customer site and all I have is an AWR report, I can tell looking at the SQL module what version of remedy they're running, because when you're running 9x, so 9.0 and 9.1, the SQL module will say JDBC thin client because 9.0 is written in Java. Older versions, 8.0 and before, were not in Java, so they show you arserver.exe. So right away, I know that the customer is running 3.9x, so they're running 8x or 7. So here's an Oracle performance troubleshooting cheat sheet. Basically, if you don't have the ability to generate an AWR report during a period when your users are experiencing performance problems or issues, have the DBA generate an ad hoc AWR report when that performance issue is being experienced. Check those sections of the AWR report. If the DBA is willing to do that, great. If not, you might want to do some reading up on just analyzing rudimentary analysis of an AWR report, especially the SQL section, because that is where your biggest bang for the buck happens. Look at elapsed time, look at physical reads, look at buffer gets. So loosely speaking, when I see a SQL statement that's doing, again, it's a rule of thumb. I'm not saying that is the case. If I see a SQL statement doing hundreds of thousands of logical buffer gets per execution, I kind of know that that SQL statement is either doing a full table scan or might be doing an index fast full scan. So those are the SQL statements I zero in right away. Ask the customer for execution plans, tables involved, the row count for the tables involved, and the indexed columns on those tables. So basically, as I said, execution plan, list of indexes. The most important thing is, as I was mentioning earlier, SQL statements, whether they're on SQL Server or Oracle, have something called an associated cost. And this cost is of that database, the SQL Server or Oracle's optimizer engine's estimation of what it would cost to run that SQL statement. And that cost is based on a whole host of factors, information, how many rows there are in the table, histogram data like how many distinct values, how long it takes to read a block from disk. So many different things go into that cost calculation. And there's, Oracle runs by default statistics at midnight every day. But of course, you can configure a non-standard statistics gathering, optimize the statistics gathering. So one of the things that you might want to do is to ask DBA, are statistics on the tables involved in the SQL statement current? Because what happens is, let's say your statistics on a table that is important are old, they're stale, so to speak. The table currently has, let's say, 100,000 rows, but for some reason, it was missed when the list of tables was drawn up for gathering of statistics, and it had 20,000 rows. I'm just making up this ridiculous example. Oracle still feels, knows or realizes or has the information that there are only 20,000 rows. So it comes up with an execution plan. But when it actually goes to run it, it finds, oops, there's all kinds of stuff happening. Of course, this is a very simplistic example, but you could find that your execution plan, is performing suboptimal operations that could be remedied if all you did was gather statistics and give Oracle the information that it has 100,000 rows, right? And so, the first thing to do is make sure your statistics occurred. And for Oracle, of course, whether you're running your database in case insensitive or sensitive mode. But for me, as someone who's helping customers with their database issues, the first question I usually ask if I see full table scans all over the place in execution plans is, are you running in case insensitive mode? Because Oracle is case sensitive by default. Oh, so you are running in case insensitive mode. Have you created appropriate indexes? They're called function-based or linguistic indexes, because your database is now expecting indexes to be linguistic, function-based, sorted as binary underscore CI or binary underscore AI, and it doesn't find them, so boom, it does full table scans. So this is a cheat sheet for Oracle, or usually the cheat sheet is similar for SQL Server also, especially the execution plans and all that stuff. Not necessarily the case sensitive, insensitive one, but the execution plan, indexes, and your statistics apply to even your even SQL Server. So here are your references. There are so many more things out there that you can look at, but the remedies, new log analyzer, as I was mentioning, your AR exception report, which shows you from the AR side, SQL statements. If you remember one of those slides, I had mentioned that 5,000 milliseconds is the default. You can get an idea of what API and SQL calls are taking longer than that configured value, 1 second or 5 seconds, whatever the case may be. Max stop, plan guide, explain plan, SQL T. As I said, SQL T is just amazing. It's insanely comprehensive. Remedy has its own 9x tuning guide that you should look at if you want more information about what to go about configuring, both for on the AR server side, the mid-tier side. Everything is comprehensive. And you have a 9x configuration checklist that you can go through to make sure that your Remedy 9 installation environment is configured according to BMC's recommended values. In summary, identify and define your slow use cases, gather the appropriate logs, narrow down the specific slow calls, get your execution plans for slow SQL, and tune those. Okay, that's it. The end. Thank you.
Great. Thank you, Rajeev. And at this time, we'll take questions. And Ruth, would you be able to provide information for our callers to queue up to ask questions?
Yes, I can. If you would like to ask a question, please signal by pressing *1 on your telephone keypad. If you're using a speakerphone, please make sure your mute function is turned off to allow your signal to reach our equipment. A voice prompt on the phone line will indicate when your line is open. Please state your name before posing your question. Again, please press *1 to ask a question. We'll pause for just a moment.
Should I go ahead and look at some of these questions and answer them? I just found a question.
Yeah. Just let's
a bell in my head.
Yeah, let's just wait, Rajeev, to see of any live callers that queue up, just so we can answer any questions they may have. And then, if not, Steve, you could redirect some of the Q&A questions we have in our pod.
And we do have a question over the phone lines. One moment, please.
Hello, hi, this is Radhika. I posted some of those questions.
Yours was the question I was going to address.
Oh, okay.
The one about it's not using all CPUs, right?
Yeah. Yes.
Okay, so that's so awesome, because last year we were involved with a very large customer on the East Coast, and they had the same issue. And basically, they had Microsoft support involved. Microsoft support came back with a recommendation that they increased their RAM to 256 gig. They had 128 gig of RAM, and they had configured SQL Server to use 96 gig of it. Microsoft support said, please increase your RAM to 256 gig, and they had a 32-way database server. Microsoft support recommended they set their max stop to 8. But even after all of that, they weren't seeing, they were seeing database server CPU usage capping off at 25 or 30%. And then it was discovered that there is, if I remember right, okay, I can try and give you more information on this later. They found that there's a parameter which basically, when you set it, it caps the CPU usage. And somehow inadvertently, that had been capped at 25% or 30% or whatever that value is. So you may want to look into that and see if that parameter that has been set. And I can later on today I'll get the details of that. It might be something as simple as that.
That's going to be fantastic. Okay.
Yeah. And
yes. All the answers that are asked will be published with the final webinar recording in a week from today's live event. Absolutely.
And your other question was virtual machine or physical server. Okay, so I haven't really encountered that many customers off the top of my head. A SQL customer that was on a virtual machine, so I haven't really encountered that many personally. But again, that's a question that we can answer later. Maybe the Remedy internal performance team has done some benchmarks on that. But on paper, I might go out on a limb and say hopefully not. There shouldn't be a difference. The only thing is, of course, if it's a virtual machine, I'm assuming I could be wrong. Am I wrong in assuming this, that you have an Uber machine that has many virtual machines configured. One of them is assigned to your SQL Remedy SQL database. As long as you don't have your Remedy SQL virtual machine lose, so to speak, resources, CPU and stuff to other virtual machines on that big server, you should be okay, I think.
Okay.
So there was a question from Rohit Varshni about the Fiddler is used for network logging. Actually, for network traffic logging, you have tools like Ethereal and Wireshark that basically give you detailed information about packets that traverse the network between the client and your mid-tier. So no, Fiddler isn't really used for network sniffing. You want to use sniffers like Wireshark, Ethereal, and other tools if you really want to get into the nitty-gritties. But loosely speaking, if you suspect, if you've eliminated other factors for your performance issues like the server itself, the database itself, your client configuration, all of these others, and network is something that you are looking or thinking of looking into or have BMC ask you to look into, I would recommend getting the network team involved because those are the people who really have a lot of experience. Or, for example, if you have a database issue, you certainly wouldn't go, you wouldn't go and have a network person involved. You would get your database team involved. So I would recommend getting network people involved if you suspect there's a network issue. Usually, we have seen some cases where the network has been an issue, but on the whole, the network tends to not be that big an issue. Usually, I'm generalizing. I know usually most of the problems I've encountered over the years working with and for Oracle performance team, it tends to be that the biggest bang for the buck usually comes from the database because that eventually is that repository of information. Your system is only as good as how quickly your data is either stored in the database via an insert update or modified via or deleted or retrieved through your select. So usually the biggest bang for the buck comes from the database.
As a reminder, that is *1 if you have a question. We'll go to our next caller.
Hi, Keith here from Videotron. The question I had is with since 9.1, interpreting like SQL commands and in SQL has been a bit different than does BMC have any tools like to better interpret like the store procedures with all the variables being passed?
You're talking about the actual SQL itself?
Yeah, like
when you see it in the database?
Exactly.
And you're talking about SQL Server especially, is it?
Exactly. Like now, like we have two commands, like one is the count, then the other one is the actual execution of the stored procedure, like with the variable of the select command. So
right.
Is it better I stay like, because we run a lot of profiling on the SQL Server, like mostly every month we'll take out like all the like SQL statements that are taking, like, let's say, more than 5 seconds or 10 seconds.
Sure,
so.
sure. So you did mention something in the beginning of your question. You said we have select a count and then the actual SQL. So I'm assuming, again, it could be other areas of ITSM, but you're talking about the overview console, for example, right?
Yeah, like we'll run SQL profiler, then we'll get out like all the longest SQL statements.
Correct.
But like when we do that profiling, like since 9.1, like the SQL statement, it's not only like the select with the work commands, like it's passed through like a store procedure with variables. So like
right.
if
So
have,
wouldn't your AR log file have those SQL statements? It would, right?
Yeah, we do have, but we'll have to get the logs also on the AR side. So, which is like.
No, I get that, but I would definitely recommend getting the AR server log files in place, turning on the logs, only because the logs, the AR server logs, will have the actual SQL, right, with the values.
Okay.
Right. So then you can take that actual SQL with the values, right, and compare it to the SQL profiler, because the SQL profiler will have those find variables in place, right?
Okay, that's good. So just in server statistics, we'll turn that feature on, right? We'll start monitoring like from the AR side instead of going.
Yeah, API from the AR side, API, filter, and SQL, especially API and SQL, and filter because so you want to know what filter fired and generated that SQL. But API and SQL are really important, and so you get this actual SQL now. Are you all in the chat? So if I post something in the chat, will you all be able to see it?
Yeah.
Okay, so there's a parameter in AR. It's called enable unlimited log. Oh, I'm so sorry. The actual parameter is something in there. See, my brain was saying something, and I was typing something else. It's Control V. Here it is. If you set this parameter in your AR server, I don't know how many of you noticed this, but your AR log file will have a truncated SQL because this parameter is false by default. If you set this to true, you get the actual SQL statement, no matter how long it is, and that will help you because if you want to run a SQL in your in Oracle or in MS SQL, the database, it doesn't help if your SQL is truncated, right? You can run it. So if you set this parameter, you get the entire SQL. So I would recommend turning on your AR logs, getting the actual SQL, and seeing if it matches up with your SQL profiler output in SQL Server especially. And then if it does, there you go. You have your SQL with all the values. You can run it. You can tune it. You can do what you like with it.
All right. That answers my question.
Oh, thank you.
Okay, well, at this time, I wanted to thank everybody for joining on this call. As always, this live webinar will be posted within a week of today's presentation, along with the Q&A and any other information that Rajeev mentioned. These will be posted, and the advertisement will be updated with all the links in this presentation. As always, you can contact BMC via the social mechanisms, as well as BMC support via web, phone, and email, and our knowledge base is available 24/7. If there's any questions, please post them in the Q&A pod, and we'll make sure those are posted with the final recording. Wanted to thank you again for joining,